Okay, recording's
Oh
on.
yes, and it would in fact be good if most people muted themselves so that we don't have to crosstalk unless you want to talk. Um, okay, so this is a meeting for people who are involved in mathlib 3 to mathlib 4 generally. So that's going to involve people who are working on the tactics as well as people working on porting individual files, and also some work that has to be done on mathlib 3 side in order to sort of prepare things for the port, make sure that the PR processes are working well, and that sort of thing. Um, uh, that said, I don't really have an agenda for this meeting or indeed for future meetings. Mostly, this is going to be sort of if you have questions, things, trying to solve some issues, we can maybe pull up the um, do some kind of pair programming or those kind of things. Anything that you think is important for people to like. You're struggling with something and you think that other people can also benefit from that sort of thing. Um, and well, okay, so yeah, that's all I wanted to say for this sort of introductory bit. Is there anything that anyone wants to mention at the moment?
Um, there was a discussion on Zulip yesterday just about the whole, like, what is the whole porting process going to look like, Flag Day, things like that. I don't think we need to particularly go over that again today, but maybe we definitely need to make some announcements, and maybe one thing we should do today is just pick who's going to make an announcement and make sure that happens in the next day or two. I think that there's basically consensus from that thread that, like, there doesn't need to be an exact Flag Day, but we really want to prioritize getting everyone across who we possibly can get across.
Yeah.
Okay, okay.
uh,
Maybe if everyone's okay, I'll write a general announcement, sort of something like that.
um,
Or
Yeah, I mean, my own opinion regarding like what are we supposed to do with mathlib 3 PRs that are sort of in queue now is that um, it's basically going to become progressively harder as things go to be able to get that stuff in, just because the amount of work that needs to be done will get higher, and my hope is that that sort of thing will sort of discourage people from doing sort of big, uh, large scale refactors of low level parts of the hierarchy where it's going to be difficult to do that sort of stuff, or at least that they take on the responsibility for doing the mathlib 4 side of things as well. And so, in that sense, it's sort of a soft freeze. It's not really, we're just sort of cooling down slowly, and eventually it may as well be frozen. Um, but yeah, I want people to have the ability to make the decision for themselves whether they think that it's worthwhile to go through the work.
I mean, I think that one thing that may be problematic is just that there are a lot of people I think who are very willing to put up a PR and then have it sit on the queue for months until it finally gets done, and that is going to become an extremely disappointing experience in the near future. I think
Mm-hmm.
we need to maybe explain to people that if you want to be making mathlib PRs, you should be sort of trying to think this. I want to get this merged in a week or not at all because things might move underneath me. And I don't. Part of that might be that we desperately need to empty the current queue in some form. I'm not sure if that's a useful thing to do
Yeah,
at
I
this
mean,
point.
I think that there's always going to be some kind of like, there's probably 100 PRs or so just at the bottom end of things, which are just sort of been gathering dust or in various stages of like they're not really moving. And I expect that no matter how things go, there's going to be a significant number of PRs that are sort of in that category when we're eventually like ready to say like, okay, mathlib 3 is basically done at this point. And we're going to have to decide what to do about those. I mean, that it's true that it's sort of a failure mode of our current PR experience. That like this is a thing that can happen because people can just walk away, right? They make a PR and then they stop responding. We end up with some kind of author requested kind of PR, and it just stays in that, or a please adopt PR, and it just stays in that forever, right? And we're, like, I'm kind of okay with just leaving them in that state, and then like if people want to eventually adopt them, they can adopt them directly from mathlib 3 to the new mathlib 4, and so it would just be left behind there basically as like something that was considered. Um, so yeah, in that sense, we can kind of continue the process of leaving them where they are.
Yeah, I mean, does
Um,
that mean it's okay with everyone if we kind of make official policy that, like, from the point of view of coordinating the port, we have like no one's going to slow anything down or take any responsibility for waiting for a PR. That it's like if you're in fast enough, you get in, and otherwise we're planning on leaving everything behind. Uh, is it okay to make that clear?
I mean, already wrote it several times, but I think we should really just stop doing mathlib 3. I mean, not tomorrow, but I mean, we should simply say that this is merging things in mathlib 3 is no longer a goal of the maintainer teams, and people can still play with lean 3 if they want, but basically we should just stop wasting energy reviewing and merging PRs in mathlib 3 if we are ready to port actual files. I mean, once the tactics are there, I really don't see the point of continuing to review mathlib 3 files.
So,
I mean, we should give people advance warning, but I think the maintainer and reviewer team should just stop doing that.
so Patrick, where would you say is the cutoff? Like, how far through porting should we be when we just close the PR process for mathlib 3? Where would you say it should be? I mean, obviously not now, and
No, no, but because we need of course to warn people. Although we've been talking about moving to lean 4 for years and years, but yeah, I mean maybe we should give people at least 2 months for warning before we stop just getting a new pull request, and then we try to merge the
well,
one.
I was thinking not so much like a time schedule, but like a porting progress schedule. Like, how far through the port of the basic stuff should we be at the point where we say that mathlib 3 is closed?
Because what is really unclear now, at least to me, but I think I'm not the only one, is whether or not porting will become easier or harder when we move to more advanced files. No, it's very hard to say because we are so low in the hierarchy, and so definitely we need to try to. When we can't decide that before trying to port at least, I don't know, basic topology files or basic measure theory files and see how it looks like.
Okay, so what if we said something like, as soon as we're at the point where we're porting basic topology, basic measure theory, basic category theory, if at that point it feels like things are going to get easier from there on, if we get any indication that it's easier, then maybe we consider being much more abrupt about closing down mathlib 3.
Yeah. But
maybe
yeah,
we can tell people that that's sort of.
already give advance warning that this is no longer in the very distant future. People shouldn't expect that we'll continue 1 more year doing mathlib 3 reviews and merge.
Yeah.
So I'm actually worried about the alternative scenario. What if it becomes harder? And I mean, then you certainly need to close mathlib 3 because if mathlib 3 grows faster than the porting process right now, that's not going to converge.
Yeah, except that mathlib 3 is, I mean, it's going slower and slower because it becomes harder and harder to use lean 3. I mean, after years of hearing Leo saying lean 3 won't be performant enough for doing mathlib, this is not happening. So it will slow down anyway. It has already started. The number of merge pull requests is lower than it used to be, and interesting things are coming.
I'm not sure that the number of pull requests is going down because of performance issues. I think that's also partly because several maintainers and reviewers are now working on the port and not actively merging.
Started to slow down before, but I don't know.
There are fewer people merging the queue.
We should. I mean, of course, we don't want mathlib4 to grow faster than the port. I mean, that would be.
Yeah, I mean, if porting is that bad that we can't keep up with mathlib, then obviously we have to accept that the project has failed at some point.
Yeah, and that we need to start over. I mean, that would be very painful. But when we did it after Lean 2, of course, the library was much smaller.
So, I mean, maybe just in terms of timescale, so something that I did a bunch of refactoring to try and get the import hierarchy to linear ordered field on the rationals as small as possible. And when I was finished with that, the depth of the import hierarchy to that point is now 25 files. And like if you count sort of the longest path down the graph. And I think that things like that maybe give us some indication of the timescale on which porting can happen. I mean, of that, we're only about depth 5 through that graph, maybe a little bit more. No, probably maybe only about depth 5. And if we work on the model that each file is a separate PR, that means there's 20 consecutive PRs that have to happen before we have the rationals are a linear ordered field, which is this nice target because it makes a bunch of tactics work better. But even if you assume a very ambitious sort of 3 days per file or something like that to go through the PR process consecutively, that's 3 months just to get to that point. Do people feel this is overly pessimistic, or?
I think that, I mean, for the specific case of rationals being a field, I think that we can definitely cheat in lots of ways in order to get there faster. The question is whether the cheating is worthwhile in the long run, right?
Yeah. Okay. But maybe leave aside the cheating. I mean, I think I agree. I mean, that's a good, but I think separate conversation. I just want to get a sense of like how people feel about timelines more than about that particular target. So maybe if we want to cheat on data.rat.order, pick another target at sort of similar level of boringness.
I'd like to know what happened to the idea that using the bin port we could work in parallel on several things at the same time. Is it already completely dead, that idea? Do we actually need to port from the bottom up everything in the order where the files are currently organized? Mario, what happened to this idea?
At the moment, synport does not work very well when you work. I mean, you would need to stub out lots of things. Like I don't think it would work that well. I think that synport has sort of evolved in the direction of not caring as much about the binport side of things, just in order to make the synport side work better. This does have, I mean, it basically means that we're choosing this bottom-up approach. So, I mean, maybe it's possible, but I have not been devoting a whole lot of time to making it work.
Okay, and what about having better tools for reviewing ported files? Can we have some meta code that checks, for instance, that every lemma has indeed been ported and that every aligned stuff
I mean,
be there?
But it's hard because often we don't want every lemma to be ported. I mean,
continually list lemmas that seem to be not ported, so that we can just check that every lemma that is not ported is indeed intended not to be ported. I don't know.
So there is a feature that will help you with this. So mathlib4 now will, when it is processing the files, if there's already an alignment, or even if there isn't an alignment, but it's like invented an alignment to a definition that exists already, then it will print the definition, the math port definition. It'll comment it out, and I'll put a little print line at the beginning to say like, oh yeah, here's the one, here's the existing thing. So that's the way that Mathport currently displays things that have already been ported. So the idea is that if you look at a Mathport output, you should be able to fairly quickly see, oh yeah, comment, 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 comment. Oh, here's a lemma, comment, 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 comment. And so that would help you tell whenever something new has been added to mathlib. Now that's not perfect. It doesn't not everything. There's lots of things in a lean file that are not definitions, right? There's attribute declarations and notations and localized instances and other things like that, which are not going to be given this sort of treatment. But for the most part, you can look at a file and tell like, oh yeah, 90% of this is commented out. This must be a ported file, and then I can just look at the 10% that's left and make sure that makes sense.
But Mario, just to clarify, that only helps you after someone has ported a file and it's been merged into mathlib4, mathport has run again, and you're newly looking at the output. So it doesn't help necessarily during the PR process, but it helps, you can look again afterwards. Okay.
Yes. There's another feature that I want to talk about, which some people are already aware of. I posted about it a little while ago, but it's basically this one-shot function in Mathport, and I think this is going to be very useful for people who are working on the port, or people who have their own files, that are not part of Mathlib that they want to get Mathported. Basically, the interface is that if you check out the Mathport repository, there is a one-shot directory, and inside that directory, there's a place where you can put a lean3 file. And then if you put your lean3, just copy your lean3 file in there, and then run make one shot, it will produce an output in lean4 syntax. You'll have to run some other, like the make there's a thing to like download the latest version of Mathlib or whatever before you can run that. But after that, the whole process, like from Lean3, it does a bunch of stuff, runs late, all the stuff that's necessary in order to run that. The whole thing takes about 1 second end to end. So it's definitely feasible to just like copy paste and make modifications and see what does Mathport do on this stuff. See that it's commenting things out because it knows that this already exists, that sort of thing. So I'm hoping that this will get better and that we can use it for in addition that we can use it for a file in Mathlib. So you can take a file from Mathlib, copy it into this thing, and then it will because it's importing other files from Mathlib and so on, that'll work. And then it will give you sort of a hot off the presses version of your Mathport of like what you would get from Mathport, but with your changes. Let's say that you make some modification. You can also change alignments, that sort of thing.
And so just to clarify there, Mario, the input to the one-shot process, you can actually give it a lean3 file and a matching lean4 file, and then one-shot will run as if the lean4 file was from mathlib4 and the lean3 file was from mathlib3, and give you a new lean4 syntax output.
Right. So the way it works is that you give it the lean3 file, and that's sort of the primary input. But you can also give it a lean4 file, which you can insert like additional definitions, additional alignments, really anything. Basically, it acts like some generic file up in the import hierarchy in which things are happening, and then that might affect how Mathport interprets stuff.
So in particular,
I think we need a video of you, Mario, playing with that thing. I mean, the video that's.
I was thinking of demoing it here, and since we're recording, there's your video.
And Johan wanted to say something for a long time. Johan.
So sort of going back to what Scott was talking about, the timeline, if one file per PR takes 3 days per file, and so we get to, 60 days before we have some basic file, I think it would be very useful to try to experiment with PRs that port more than one file. maybe 5 basic files in one go or something like that.
Yeah. So there's already
I have no idea whether this is realistic, but
well, there's
I-
already
I
one
also
such
think
PR up
mentioned, though,
there.
that they don't have to be serialized completely. Like it can be dependent PRs, right? You could produce a PR for the first thing, and then produce a PR for the second thing, which says depends on the first thing, and then the turnaround time is like somewhat pipelined because the reviewer has some amount of time, and you don't necessarily have to go like author to reviewer back to author back to reviewer. You could have author does a bunch of things, and then reviewer goes and checks all of those things, and so the total timeline could be less than 3 days each, even if the latency is 3 days.
Yeah. So two things on that. I mean, one, I think it's actually a great idea that we get in the habit of moving on to the next file before the first file is done in the form of stacked PRs. In part, just because it gives you confidence that you've done the first file reasonably well if you can do the next file down the hierarchy. But the second thing is that there's already an example of this up, Johan. There's a PR that I put up and then partly abandoned and haven't looked at for a couple of days, but that does like fun-like, basic fun-like equiv and fun-like embedding just as a single. And those are obviously kind of a linear chain of 3 in the hierarchy. And especially I think when you see like an isolated linear chain with no other imports coming in, it's a great idea to just put them all in one PR. And I think hopefully we can do that. The other thing to say is like that sort of depth 20 remaining to get to linear ordered field. A huge amount of that are just definitions files now, which hopefully are all trivial ports, and maybe even like I posted a while ago the new import hierarchy for just the definition of a field. There's no reason that can't be done in a single PR now. Just all of the algebraic hierarchy up to field in one go. Order will be harder because lots of lemmas come in on the side on the order hierarchy.
Can I interject a piece of technical information? So I actually just came from talking to the campus IT people about the new build servers. So we did figure out what was going on with the 2 new machines, so we should have them up and running pretty soon. But he also did express concern that actually that the servers have been kind of running and using up a lot of time, and they don't think that they're worried that they can't handle anymore. So he said that they would look into it and happen. So we may be bumping up against the limits of not what they'll sell us, but what they can sell us, what they can give us. So I will keep you posted on that.
Do you mean that we're using it too much of the time?
Yeah, so I mean, basically the virtual machines are running on actual machines, and their actual machines are, I think weren't expecting to have so many virtual machines running so much.
So I can try showing how the one-shot mode works. Let's see if this works.
I'm just going to drag this back over so people can see it work.
Okay. So if you get the mathport repository, then it has a section explaining how you can run one shot. So basically there's 2 files that matter. There's this lean3in and then the lean4in. And in the lean3in, you can put in some test like this, and then you run make one shot, and hopefully this works good. And then it produces this. And so this is essentially the math port output that you get. and so you can experiment with like having different, like this example is showing like, oh, how to calc blocks and begin end and all of that, that gets changed. And I'm probably oh yeah, and then you can, so like if we let's see if I can give an example. If I go and get logic, so this here is logic.basic, which I just copied, and I'm hoping this will work and it won't recompile all of mathlib. Good. And it produces this. And so you can probably, so since logic.basic is a already ported file, you can see the things. So here we can see like, here's a bunch of lemmas that have already been translated, right? So it's printed, commented out. There's actually some options in mathlib4, but this is the default settings to show both the output that mathlib4 would have produced, and then also, oh, and by the way, this was already translated. But you can also change it so that it either just ignore it, that it prints like this, or that it removes the lines entirely, depending on what you want. And in some cases, let's see, there were some examples earlier where this happens, I think. So you'll get this error here. It says, warning, this is a dubious translation. And what it means by dubious translation is that it translated the Lean3 declaration and it got this expression. So this is the type of this theorem after translation from Lean3. And then it was aligned to a Lean4 definition that exists, but the Lean4 definition has this type. So if you look carefully, you'll notice that the difference here is that the Lean3 declaration works on types and the Lean4 declaration works on sorts. So there are a couple ways you can handle these sorts of dubious translations. One way is to align it like this. You put a subscript X after the name of the Lean4. So this is the Lean3 name and this is the Lean4 name. And if you put a subscript X, then it will, what it'll do is it'll translate it to a new declaration with this type. And so it won't have type errors. But when it prints it, it'll just remove the X. And so it'll look like there's another definition called EQ if cancel left. And if you actually parse this, it would produce a duplicate definition error, but then you could like remove it. And then later things which are referring to the EQ if cancel if left X would look like they're just referring to the EQ if cancel left. And because these two declarations have basically the same type, everything would just kind of work. So the other alternative is if which is like actually different. Like an example of that is the stream type. So Lean3 has a stream type, which is basically functions from nat to alpha. And Lean4 has a type also called stream, but it is a completely different thing. It's I think this can get something working. No, this is sorry. So if you look at stream, it is actually this thing which is about like external iteration, or this is something to support do notation, for loops, something or other. So it's basically a completely different definition. And when you hit that kind of thing, you probably just want to rename it So that would be something like align, it would be align lowercase stream because it's the lean3 declaration, and we're going to align it to stream prime. And so now we would end up, so when you do this kind of alignment, the math port output will refer to stream prime instead of stream, and then
Has Mario frozen for everyone, or?
Yeah, we lost.
Okay.
Frozen for me.
everything he has lost.
There we go.
Oh.
Okay. You're back. So,
Yes.
Mario, could you explain again how the hash align worked when you put a subscript X? I don't think I understood that.
Completely missed that. Yeah.
So when you put the hash align, it will so basically there's this when mathlib4 is running, it's producing sort of a shadow version of the lean4. It produces an environment, and it extends that environment with versions of all of the commands that it is adding. So like when it writes down a command, it adds that theorem to the context. The thing is that when it produces these theorems and so on, they're often like, there might be some syntactic or elaboration issues or something like that. And so for the most part, they don't actually type check. And so because of that, what it's actually doing is it'll add like a stub version of all of these definitions. Like whenever it adds a definition, it'll add, it'll do its best approximation of that definition, and it'll add that, something that's type correct. Maybe it might even just be unit, but something.
So
in order so that it knows that this definition exists. And then later, when it's like processing things, it can look in the environment.
So just to clarify that, when you're saying it adds these stub definitions, this is during the run of mathlib, but at the end of the day, when you have a mathlib4 file which you're looking at in isolation and it has a hash align there, it has no effect in mathlib4 per se. It's only during the math port run that any stubs are being created.
The purpose of align statements is not to do anything inside mathlib4 itself. The purpose of an align statement is to direct what mathlib4 does when it's running. And that affects the output that it produces. And this trick with the subscript X is basically we're affecting mathlib4's inner state while it runs, but then when it prints it, it removes the X's again. And so the final file that you get doesn't have the X's in it. And so this is one trick that you can use in order to try to get a better approximation to a well-formed lean file, which will then help with people doing editing after the fact.
When you say print it, you mean write the lean file, the lean4 file, not print it on screen?
Yeah. Right. This is printed.
Because you had the dash print commands in your file.
Oh, yeah. The print commands are just for viewing, I guess. Okay.
And the lean4 output of the one-shot thing was meant to compile, or it was not clear whether it was an error-free lean4 file or whether it was just not compiled at all.
Yeah, I mean, so there's still, I mean, they're basically subject to the same issues as regular ported files. So they'll start out like not compiling at all, and then with a little bit of editing, you can get them to be or mostly compiling. Let me. Oh, I guess I'm not sharing my screen. Well, I can't share my screen. You're not seeing my screen, are you?
No.
No.
Well, they don't. So. Yeah. Okay. Maybe I'll just restart. I'll be right back. You're seeing my screen right now, right?
Yes.
Yes.
Okay.
It's all right.
Okay. I'm hoping. Well, maybe I'll copy this into mathlib instead. Hopefully that will be better.
By the way, I think it's really annoying in Lean4 that when there is any error with the import, Lean4 just completely goes crazy and refuses to do anything.
I agree.
Yeah.
It wasn't like that in Lean3.
What does it do? What should it do? I'm not even sure. I mean, okay, so we know that the import error message is extremely bad. There's a lake issue that's covering this. I mean, what basically happens here is that you can see that Lake tried to run a thing, and then it just prints whatever was outputted to standard error, which, it's usually quite difficult to read and so on. I guess the error that we're getting here, though. Okay, yeah. So we can make it work, just because I guess those files don't exist. I'm not sure whether those files have been ported. And let's see. Well, okay. I guess we do have to. Maybe we should import logic.basic, which is this file. So I guess those things should all. Okay, so now this is looking a little bit better. So we get a bunch of prints and decide. So for the most part, instances are not being aligned. It's kind of annoying to align instances because you have to know what and in Lean4 you can hover over the word instance in order to see what it's annoying to have people come up with the alignments for those examples. So for the most part, we aren't aligning them unless it becomes really important. Like if someone refers to one, like in this case, then you edit it or something. So that's why that's on.
In particular, there when you say and then you edit it, you mean you go back to the relevant file where that instance was created and you put in the align statement so that people in future don't have to edit it. Is that right?
Yeah, you can either write an align statement or
Excuse me, do people hear Mario?
Yeah, no, I think Mario's cutting out. I can't hear him.
Yeah.
Oh, you can't hear me.
So you got as far as you can either write an align statement or.
And then my internet cut out slightly. So you can either write an align statement or you can make a modification on the spot.
Okay,
so
but if
in this case, you could just change this to refer to the right thing.
Sure, but the point is, if you do it on the spot, then everyone else runs into the same problem downstream.
Right. Assuming that there is a downstream.
Okay.
Like if it is very common for people to be referring to and up to decidable, then okay. It's quite possible that the only reason this is referred to is because of this inline attribute. I'm pretty sure that in the actual logic.basic, we just commented this out. Yeah, see, here's the original line, and it was just commented out. Yeah, so this is the state that you'll usually find math-ported files in. So there's like a significant number of errors, but also a reasonable number of non-errors. And then fixing this is what porting is basically at this point. And
how bad are these dubious translation errors? Because to me, from what I've seen, the dubious, like the way that it's translated doesn't seem like it would break anything. How do we know that it? How?
So the dubious.
Sorry, Mario, you're cutting out again. Yeah. Okay, I think you're back. Yeah.
The dubious translation errors could be completely different types, or they could be almost the same. They could be like implicits are the wrong order. The implicits are the wrong order is, I usually fix that by putting the subscript X afterwards. Or like universes don't match. If it's like really minor stuff where like if a human was to write it, they wouldn't have noticed at all. Then in that case, I would put the subscript X.
So can you just explain, so if you're in that sort of situation, say the implicits are in a different order, and you just delete the comment about the dubious translation, you don't add in a line and just proceed, what is going to happen down the track?
Don't add a line. Nothing much. So the relation is that Mathport will take a dubious translation and use it in all later things, and that will almost certainly cause type errors in every use of that constant. Those type errors, because this is just in the shadow state of of this thing, what that will cause is it'll start degrading the types, and then that will cause more degradation of the types. And if you actually look at the result of this shadow state after running one of the files, you might see that like almost everything is just unit because the types have just completely fallen apart. The main user-facing thing that you'll notice as a result of this is that Mathport seems to be doing much worse at guessing how to camel case or snake case stuff, because it can't figure out whether anything is a theorem or a definition, because it's got the types all confused.
Okay, but the conclusion of all this is that when you're porting, when you get a dubious translation warning, you should first of all check if it's a minor discrepancy or a major one. If it's a major one, you should work out what you're meant to be aligning to, because the names of things have radically changed. And if it's a minor one, which is just about implicit arguments or universe levels, you probably should be adding the hash align with an X. Okay.
Yeah. You probably shouldn't just leave the dubious translations, because these type errors are going to cause worse problems down the line. Okay. If it's like something which is definite, like one thing which you can do, but I'm not sure how reliable it would be in practice, is if you have like a whole bunch of definitions that are switching to something that is not definitionally equal, but like that well, if you applied the new thing to the other new thing, then it would type check, and the old thing to the other old thing would type check. But if you apply the old thing to the new thing, those wouldn't type check. Then it might still be okay to do the alignment to the new thing. Yeah, I mean, basically Mathport's going to take your word for it and just try it, and if things go wrong, yeah. So
In the example here, though, to me, it's better because it allows for more universes.
Yeah. No, I mean the other thing is we could also backport some of the change. If it's little things like different order of implicits or more general universes or something like that, backport it. It might just be too much hassle to bother with these little things that come up all the time. Like you'd get tons and tons of these minor changes, and I'm not sure how much to care about it. It's like as long as Mathport can just kind of transparently make it work, it feels kind of okay to just do it during the port. But yeah, we could port this, and then this would become an on the nose translation. That'd be better.
Maybe it's irrelevant, but where do those universe discrepancies come from?
Well, this was just the original definition was so this is only looking at the type of the declaration, not the value of the declaration. So this theorem was proven in a slightly different way, and the slightly different way allows for more general type, I guess. It might be that like no one noticed, when you write sort star and you use it in a place where type U is expected, it'll just silently become a type star, and you might not even notice until a while later. So yeah, I'm not exactly sure what's the cause for this EQ if cancel left. Yeah, the original code does not give any indication that it's probably a variable. Yeah, okay. In the original code, their alpha was a variable. This alpha here, there's a variable alpha : type star at the top of logic.basic, and so everyone's getting that, and it's probably true for 90% of the examples. But in Lean 4, because of auto implicits, you can often just not have a variables line, and then everyone gets the most general thing. And I mean, auto implicits have downsides as well, but sometimes it can allow you to automatically get these sort of more general types.
Shouldn't we just switch off auto implicit in mathlib4? I mean, for now, it's only creating complications.
Oh, no. Auto implicits are great. I like them.
That's the first thing I switch off when I begin a port. I just import library search and switch off auto implicits. But then at the end, of course, I delete it all.
Because this makes errors much harder to notice when there's auto implicit.
I know, but only when porting somehow. It's really cool having that. I was just showing off some Lean 4 at Xena this evening. And it's like, yeah, you just don't need any variables. Yeah, I just wanted a binary relation R, so I just called it R, and Lightning just made it.
If auto implicits were off for things that are longer than one character, I think that would.
That was the original setting.
That's right, but sometimes in porting, you might not notice that it's referring to a term that is now snake case, but now it's camel case. But because it's snake case, it's an auto implicit.
Right. That's why I switch it off, and then you just notice them all immediately.
Right.
Exactly.
So
I think for new code, it feels very convenient to have auto implicits. I agree that for porting code, you're never going to use auto implicits in a Lean 3 file, a ported Lean 3 file, right? The way it's written is just always going to not need it. So I think that Kevin's approach makes sense. You just turn it off while you're porting, and then afterwards.
Mario, how about we just change mathport to turn it off in all of the produced files? And People can remove it if they want before they make the PR, and if they don't want to, it's fine. We can do a mass cleanup in a year's time and remove all of the disabling auto implicits. It's
We just need a hashtag port mode that is like some command at the top of every file that is being ported.
I think
It does a bunch of settings.
We may as well. Like if there's some couple of lines that people are copying and pasting into every file before they start porting, Mathport should just do it.
Yeah, but I mean, people might have different opinions about which lines. Yeah, I always import library search because I'm clueless, and library search is a great help. But I mean,
Well, I mean, for that one, we should just import library search at the very bottom of the hierarchy. Just import it in logic.basic and call it done. And later on, we can take it back out again.
Well, we've also got STD now, right?
Yeah. Yeah, and library search should eventually move
So-
to STD as well.
I think a lot of things, including library search, could probably move to STD. And import STD appears in several tactics. You can probably put it in tactic.basic. I think that in the long term, we probably want to have more targeted includes of both lean and STD. But for the near term, where near term means like a year plus, I think that just having an import STD is just to save people the trouble.
Mario, what do you think of the idea of turning...
and then also import mathlib.init and everything. I mean, that's a new import, which represents everything from from the old Lean 3 core, right?
So, Mario, what did you think of just disabling auto implicits in Mathport?
I see. So you would print an extra line saying like set option
Exactly.
false.
Yeah.
I mean, we can do that.
Yeah, let's do it. I like it. It'll make Kevin and Patrick happy.
I mean, we could also wrap that behind like a port commands. There's something like just mentioned.
So, Yakov, could you explain your comment about assistance for generating hash lines?
Sure. So there's a lot of renames from snake case to camel case, and they don't. That sort of conversion doesn't occur in lemmas that mention the names of the new objects. And we've talked about how exactly it should be cased, whatever it is. Mario mentioned, well, how is it supposed to know in the lemma name what to change, because there's other underscores around it. We can come up with some heuristics, but right now for me, there's the old name, I yank it down, I write hash align old name, write the new name in the place where it's now correct, and then include that for the new name, and then have to do it for each one. I guess I could come up with a way to have some really smart set command that does a find and replace snake case to camel case, but not on the lines that have a hash align in front of them, because you don't want to actually find and replace the original name. So something there. Either Mathport tries to guess what you would want to align the new name for if it finds the snake case substring in the lemma name and the object itself in the type, or whatever it is. Even if the align suggestion isn't perfect, it's easier for me to delete or edit an existing suggestion than to write one anew. I just haven't come up with the right VS Code or Vim macro to help me here.
So I don't understand. Like, if Mathport had suggestions about the hash align commands to make, why wouldn't it just name the lemmas according to those suggestions? I'm not quite sure what you're asking for.
Well, we would still need the align command, correct?
Okay, sorry, yeah.
We need two things. We need the lemma renamed, yes, and right now it's manual renames and manual writing the aligns. And it can't just up and go change the lemma name because it's used downstream. But the same way we have a dubious translation thing, we're going to have like you probably want to rename this while you're porting. And here's the new name that you probably want, and here's the align command that you probably want.
Wait, so how do we predict when you want a different name? That's the part I don't get.
Right now, I'm thinking of something like lift or get. So lift or get became camel case. Now, if we see lift or get mention snake case in a lemma name, and lift or get, the term itself is mentioned in the type, then you know, oh, this lemma is about lift or get, so I should probably replace lift or get snake with lift or get camel in the lemma name.
Yeah, but let's say that we know that and we implemented that kind of heuristic, then why wouldn't mathlib4 just use that as the new name? No suggestion of a line.
Yeah, totally. I see what you're saying about the. I see what you're saying about the.
Yeah, I mean, I think the difficulty here is just making mathlib4 smart enough to have guesses in the first place about the new lemma name, and then if we had those guesses, we could do the renaming automatically and add the hash align automatically. The problem is just that making those guesses in any principled way is confusing.
So without getting into like what heuristics there are, I think just, you know, I'm just saying I'm getting annoyed by copying and pasting the line and jumping back and forth, and I don't yet know what a better way is, and so I just wanted to bring it up. I don't have an implementation solution. I'm happy to hear that. Hey, just write it yourself.
So I thought about having like a way to auto suggest align things which would use the names that it already uses, but one thing is you can't do that inside mathlib4. Like when you're editing a mathlib4 file, it would be nice if you could say have a way to like have like align auto suggest itself or be a try this or whatever. But the issue is that the align directive or like where you're writing in mathlib4 doesn't have enough context to actually be able to do the camel casing correctly, because it doesn't have the lean3 sources. It's not mathlib4. It doesn't have any information about what mathlib4 is doing. It would only be mathlib4 itself that could, for instance, add additional, like you could have mathlib4 produce align statements for every declaration. That would be kind of annoying for all of the declarations where it's not needed, but at least it would give you some copy and paste material. So I don't know whether that's a better idea, but like it is definitely capable of printing like align statements for the alignments that it did do. And that would give you your snake case to camel case stuff. And maybe it's the, you know, one of the declarations is slightly different and then you can modify that.
Right. I think it's going to be on a file by file basis. Some files you definitely don't want them, and some files you really don't need them. And some files where you have a particular definition and proofs about it right away, then you really need it. So I think it's bimodal.
I mean, could
in that case, could it be something that like the mathlib4 one-shot does, like optionally?
Yeah, I mean, so mathlib4 has a configuration file. So there's this thing config.json, and you can put additional. We're working on little ways to tweak things, like this replacement style comment allows you to change the way that those print lines show up, and you could put something else there. You can add more options, and so we could do something like this where you edit the config.json and then you run mathlib4 one shot, and then let's say that it's not a default option, but we can say print all the lines, and then you could just copy and paste. You can one-shot the single file that you're porting with edited config, and then that would allow you to, adjust how this thing looks. So that might be a good way to solve this sort of bimodal thing.
Another solution that isn't quite as clean, but on the other hand doesn't require people running one-shot at all, is just that we default to printing all of the hash lines, just because it's relatively easy to delete all of the hash lines if you decide you don't want any of them. That's a single search and replace in VS Code without any thought, but it's much harder to create them. They're also harmless if you create them automatically and don't delete them.
I guess it's my internet.
We could do a wider
Well, we're at 1 hour, and I don't think that we want this to go on forever. So let's unless anyone has any last thoughts, let's call it a day.
I could just comment that Anna Barnum's there's weird breakage in hash 559.
Mm-hmm.
We need expert help with 559 because the code is crashing a linter.
I see. Post about it on mathlib4 stream.
Okay. No, I think Anna already did. They said, "Can anyone help me debug this?" But it's now relevant to me because I have a PR that builds on theirs.
Okay. Thanks everyone for coming. It's a great turnout.
Maybe I got one more thing. I've seen many people here that I actually don't know. It would be nice if we could take 5 minutes just to tell everyone who is who.
We could do that at the beginning of the next meeting.
I think that's a better idea. We've already lost some people.
Okay.
So you all have to come back so that you can introduce yourself.
Okay. Let's do that next time.
Okay.
Well, thanks, Mike.
See you.
See you, bye.
All right.